Okay, now we're looking at the distance between any 2 points. In our first lesson in this section, we were looking at the distance between the origin and a point, but this is between any 2 points on the Cartesian plane. So we're going to look at point A, which is at -7, 8. So -7, 8 should be right about here. And the point at 5, -2. So 5 is here and -2 is here, so that should be this point. So here's point B and here is point A. And we're going to do what we did in a very similar fashion to the investigation that we did on the first day when we found the distance between the point and the origin. So we're going to create a line line segment joining these two pieces together. And that did not work very well at all. Undo, undo. Let's see where we're at. There we go. Let's try that again. I'm going to have to freehand this. I hate freehanding on this. I would really like to use a ruler because I like to be precise. Okay, so there we are. Join the 2 points. Create a right triangle just like we did with our other one. This time we're just not using the axes in terms of the x-axis heading over and then heading up how much. So we can go either direction. I can make my right triangle this way. I could have made my right triangle the other way. Doesn't really matter which way we go with this. Okay, so either way works. So whichever you did was fine. What we need to figure out is the rise and the run. Now, if I count squares, I could figure out the rise. So my rise, if I'm going from B to A, so in the green, since I already have my green pen, I've got 8 units plus an extra 2. So this should be 10 units here. And then to the left, to go from B to A, I'm heading, let's see, we went 5 to the y-axis and then another 7 to get over to 8. So 5 and 7 collectively make 12, but I went left. So that's really -12, or if I'm just looking at it as a length, it'll be just plain old 12. If I look at the red and heading from A to B, heading downwards, I would have gone -10 and then a +12. Now these values for rise and run, again, really fit in with what we've done in the past in grade 9 with slope, because I know that I can get this run of 12 here by taking my x-coordinate. If I took my x-coordinate from point B, so x from coordinate from point B, and if I were to subtract my x-coordinate from point A, that really is my run. And my x-coordinate from point B was 5, and then we're taking away my x-coordinate from point A was -7. So 5 take away -7 is that, yep, that gives us our +12 from there. The -10 really is our rise. I'm really taking my y-coordinate from point B and subtracting my y-coordinate from point A. So that was -2, y-coordinate from point B, looking up here or looking at my diagram, minus my y-coordinate from point A, which is 8. That is where my -10 or my run comes, or sorry, my rise comes from. So again, we can use Pythagorean theorem to find the length of our line segment. We know that the c squared, my hypotenuse squared, would equal -10 squared, or we can just use 10 because it's just a distance. When I square it, that negative is going to become positive anyway, plus 12 squared. So that would give me 100 plus 144, and that's an answer of 244. So that's the length squared. Now what I need really is the c. The c would equal the square root of 244. That is my exact value, which can be approximated to be 15.6 roughly to 1 decimal place. It's 15.6. If you go to 2 decimal places, it's 15.62. We'll just leave it at 1. Okay, so we're going to use this information to make a generic formula for anything. Okay, now connections here that I need you to see is that the -10, this really ended up being my rise, and this 12 really is my run. And when we were working with our point, a point to the origin, my rise and my run, my rise was really my y-coordinate minus 0, because my second coordinate was just 0, 0, which ended up giving us that y squared. So the rise squared was that, which gave us a y squared. My run, I found out from the other investigation, was x take away 0, all squared, which ends up just being x squared. And then my equal sign didn't come through there. Okay, so we're going to use that information to come up with a generic formula on the next slide. Okay, so what's the formula for finding the distance between any 2 points? And we'll call it point A and point B, and I've labeled it XA and YA, or some of us last year would have called this X1, Y1. That's the same thing. It means it's just a different notation, but it's really talking about the same thing. And we could call this point 2, and then it would be an X2, comma Y2. So if you're more comfortable with using 2's and 1's rather than the A's and B's, I'm perfectly fine with that. All right, so you're going to put 2 points anywhere on the Cartesian plane. Does not matter where, okay? You can make your slope positive, you can make it negative. I'm just going to pick 2 spots. Doesn't matter where. So there's my A, which is at XA, YA. And here's my point B, which is at XB, YB. Okay, so I'm using the A's and the B's to distinguish which one came from which point. And then we're going to join those together. We're going to create our right triangle out of this. It doesn't matter which direction the triangle goes. I know that my run, this number here, can be earned by calculating my X and B, take away my XA. That's how I get that distance there. And my rise, this is my rise, it's equal to my YB minus my YA. And so therefore, if I want to find my my hypotenuse, which is the length between those 2 points, I know it's really C squared equals A squared plus B squared. Or in this case, it's really my rise squared or my run squared. I'm going to put run first. It doesn't really matter. I'm going to put run first because it deals with the x's first. And then plus my rise squared. Okay, now run, we know from when we calculated slope back in the day, way back in those fun grade 9 days. That is my xb minus my xa, all squared. And my rise is my yb minus ya, all squared. Or for those of you who likes the 1's and the 2's, it could be x2 minus x1. You'll see this in textbooks sometimes, squared. In fact, I think our textbook uses the x2's and x1's and the y2's and the y1's. Oops. Y2 minus y1. I don't care which one you use, just use one. Okay, so this is my generic formula for c squared. If I actually want the value of c, what I do is I square root both of those sides. And you will see this crazy looking formula, but if you just remember it's rise squared plus run squared, or vice versa, run squared plus rise squared, it's really easy to remember. Okay, next. All right, so to determine the distance that a point is from the origin, I tend to still go back to the fact that distance squared is equal to, and if you want to put in here your rise squared or your run squared plus your rise squared, you can do that to remind yourself that that's what that is. That's really going to be equal to, d squared is really equal to, bracket, my rise is my y2 or yb minus ya squared plus my xb, oops, I used 2's on this side. Better put a 2 there to match up with the y's, minus x1 squared. So that's my distance formula, the distance squared. The d then is the square root of that. So if you see this funky looking thing in your textbook, and I flipped over to the y2 minus y1 only because your textbook uses that, but you can use the a's and the b's instead. You just want to be consistent with your subtraction, that you do it in the same order. Take the point from the one, subtract the coordinate from the other, and do it in the same consistent manner. So it's the y2 minus y1, x2 minus x1. Okay, so there's our formulas, and then it's just a matter of using that formula to calculate the distance between them, the 2 points that are given, and calculate the slope of the line segment joining them. So put me on pause, try it out, check your answers. Okay, so I've calculated my distance between A and B to be 13 units. When I go to calculate my slope, I just wanted to outline this for you. Slope I know is rise over run. And if I look at my equation, if I've set things up nicely, I know that this stuff corresponds to this, corresponds to this. So I know from my calculation above that my run has a value of 5. And I also know from my calculation above that YB minus YA, and again, as long as I've been consistent in my order of subtraction, my sign will work out just the way I need it to. My rise is negative 12. Okay, so my slope in this case is a negative slope. If I actually graph them and join them, my little line segment should be going up and to the left or down and to the right, and it should be fairly steep if I'm working with a 1-to-1 ratio on my axes. Okay, if you haven't done part B, then put me on pause and do it. Otherwise, go ahead and listen and check and see how you did. Okay, for my second example, part B here, I got the distance to be approximately 7.8, or the square root of 61 units. The slope, I went back to my calculations from above since I've already done all that work. The rise was negative 5, the run was negative 6. Negative divided by negative is positive overall, so my slope ends up being 5/6 at the bottom.